Hi everyone, it's been a long time since I've made a video to help out with maths, but I had a request for a bit of extra support with simplifying index expressions, and I thought I would make a video with a couple of examples. So these are from the questions that were set in class. If you're having trouble, hopefully this helps. I'll try and break it down as much as I can. So in this problem, we're trying to simplify. Now, normally when we're simplifying, the first thing we look for is to have a common base number. And my problem here is my base numbers are 36 and 12. So they're not a common base number. So there's a few different ways that I can tackle this, but my primary method is I'm going to break this 36 and this 12 down to their prime factors. So I'm going to do some prime factorisation. So how do I do that? Well, the quickest and simplest way that I have used in the past is to create your basic factor tree. So I know that 36 is the same as 12 times 3. 3 is a prime number, so I'm going to stop there, don't need to go any further. 12 can be factorised into 3 times 4. Again, 3 is a prime number, so I'm going to stop there. 4 can be broken down to 2 times 2, and 2 is a prime number, so I'm going to stop at them. So when I create this, I end up with 36 is the same as 3 squared times 2 squared, because I have 1, 2 3s and 1, 2 2s. Or if you would have preferred, it's 3 times 2 times 2 times 3, just by moving along my tree like that. Okay, do the same with the 12. Prime factorisation, use my factor tree. 12 is the same as 4 times 3. 3 is a prime number. 4 is the same as 2 times 2. They're both prime numbers. So I've got my prime factorisation here. 3s and 2s. Follow this along. 2 times 2 times 3. 12 is the same as 2 times 2 times 3. Or 2 squared times 3. So my purpose for doing that is in my original expression over here, I can actually now break this down into its prime factors. So my 36 I'm going to write as 3 squared times 2 squared, and it was to the power of n. And my 12 is the same as a 2 squared times 3 to the minus 2 to the power of n. Okay. Now that I've got to this stage, I can start simplifying my index expression. So I'm going to go to my index laws for this one. So when I'm doing my index laws, I always start with the brackets. We've got 2 sets of brackets, and this is what I call a power to another power. So when I have a power to a power, I multiply the powers. So for this first bracket, I'm going to keep the base and times the powers. 2 times n is 2n. Keep the base, which is a 2, times the powers. 2 times n, 2 to the power of n. Then I've got another times sign. That times sign comes down. Second bracket, keep the base, it's a 2. Multiply the powers. 2 times negative 2n is negative 4n. And then my base number is 3, my power is 1. Keep the base, multiply the powers, 3 to the power of minus 2n. So we've got rid of the brackets, and now we have either a base number of a 2 or a base number of a 3. So I'm going to work with those bases separately. All right, so let's move on. Next index law. When I multiply, I have to keep the base number and add the powers. So when I multiply, keep the base, add the powers. Let's start with the 2, and then I want 2n plus negative 4n, and I'm writing the extra step there. And then for my base of a 3, I keep the 3, and I'll have a 2n plus negative 2n. All right. Simplify that down a little bit. I get 2 to the power of negative 2n times 3 to the power of 0. Now we stop and look again. Anything to the power of 0, a power of 0 is always equal to 1. So this part of the expression will be equal to 1. and I haven't done anything with the 2 to the negative 2n. And I could actually stop and say that my simplified answer is 2 to the power of negative 2n. But normally when we're simplifying, what I've asked you to do in class is not leave negative powers. Let's always try and have positive powers. So now I'm going to work with this negative power. And my trick that I had here is if I ever have a negative power anywhere in an expression, let's say I had a to the power of negative n, and divided by b to the power of negative m. If it's ever a negative, this is saying, no, I'm negative, I'm sad. Sad face, I'm negative. I'm not happy. And the reason that this index is not happy is because it's not where it belongs. And where it belongs is actually going to be on the other side of the vinculum line. So this wants to come down here to be happy on the bottom line. So that a to the power of negative n is going to move to the bottom line, become a to the power of positive n. Obviously, we don't need to write the positive sign. So it's just a to the power of n. And now this is a happy index law. I'm happy here. Same thing with the, again, talking about this expression here. I've got the negative m. That negative m is saying I'm unhappy. And the reason it's unhappy is I'm in the wrong spot. How do I make it happy? I move it to the top line where it will be a happy little index. So it will be to the power of m. I'm happy here. That's positive. So same thing over here. That's my ridiculously silly way of remembering where my negative powers should go and how to manage them. So how do I do that with this problem? Well, I have a negative power. So this negative power, I'm going to move to the bottom line of the denominator and make it positive. But I can't just leave an empty space up the top here. I have to have something on the numerator of the fraction. And so my core base number is just going to be a 1. So my final answer is 1 over 2 to the power of 2n. And if you wanted, you do not need to do this, but it could be a possible multiple choice answer. This could have been 2 to the power of 2 times, oh, that's not 2 to the power of 2, mistake there, sorry. 2 to the power of 2 times 2 to the power of n. Why would I do that? Because I can make it 1 over 4 times, oh, I think I made another mistake there. What am I doing? 4 to the power of n, that was wrong. Sorry, let me explain that again. Made a mistake at the very end of the video, which is annoying, but we'll get it right this time. That 2 to the power of, this is like having a power to a power, so it could be 2 to the power of 2 to the power of n, which would be equal to 1 over 4 to the power of n. So as I said, you don't need to do that. This would be given 100% correct marks, but if it was a multiple choice question, it is possible that they would write the answer like this, and that would also be correct if you wanted to go that little bit further. Okay, that's the end of my first example. I'll create a second video shortly.